Hello students, welcome to the second part of design of helical gears. Here we will take up a problem and see how a pair of helical gears can be designed. This is the problem. Design a pair of helical gear to transmit a 12 kilowatt at 1200 rpm of pinion. The velocity ratio is 3:1. The pinion has 24 teeth and is made of carbon steel having design stress of 86 megapascal. The gear is made of cast steel having design stress of 51.7 megapascal. Teeth are 14.5 degree involute and helix angle is 25 degree. So these are the given things. Power to be transmitted is 12 kilowatt. Velocity ratio is 3:1. And pinion speed is 1200 rpm. Pinion material is carbon steel. Its design stress is 86 megapascal. Gear material is cast steel. Its design stress is 51.7 megapascal. Number of teeth on pinion is 24 and helix angle is 25 degree is beta, and helical gear tooth system is 14.5 degree involute. Now, as a first step, we know that the velocity ratio is given as 3, that is n1 by n2 equal to 3, and which is equal to, that is I equal to n1 by n2 or equal to z2 by z1. So this I value is 3, n1 is given as 1200. Therefore, speed of the gear will be 400 rpm. Similarly, by using this relation, we will calculate the number of teeth on gear, which is found to be 72. By using the value of Z1 and Z2, we will calculate the virtual number of teeth on pinion and gear by using these relations. So hence, we will get the formative number of teeth or virtual number of teeth on pinion as 32 and the virtual number of teeth on gear as 96. Once the virtual number of teeth are calculated on pinion and gear, next using the Lewis form, using standard equation, we need to determine the Lewis form factor for gear and pinion by using the virtual number of teeth information. So this is y1 for pinion and this is y2 for gear. Then calculate the product sigma d1 y1 for pinion, similarly sigma d2 y2 for gear, in order to determine which member is weaker, whether pinion is weaker or gear is weaker. So for pinion the product is 8.83 and for gear the product is 6.04. So this product for gear is very small compared to that of pinion, hence gear is the weaker member and a design will be based on gear. Okay, then once the weaker member is decided, in step 2, the tangential tooth load based on power transmitted will be calculated by using this equation. Power is 12.5 kilowatt, CS assumed 1.5, and V, the velocity is pi d2 n2 divided by 60 into 1000. So substitute for d2 as module into number of teeth, because d is equal to m into z divided by cos beta. This divided by cos beta. For d2 equal to m into z2 divided by cos beta. So by substituting the values, you get v equal to 1.66 times the normal module. And substitute that here and simplify this, you will get ft equal to 10843.37 divided by mn. Let it be equation 1. Similarly, calculate the tangential tooth load based on the standard Lewis equation for helical gears. So this is the equation sigma d into cv into d into y into mn divided by cw. So here the parameters or values of gear will be used because gear is the weaker member. So sigma d2 into b into cv into y into mn. B will be same for both pinion and gear. It is not a problem. So substitute all the values. Assume b equal to 20 times normal module. As you know, capital Y equal to small y2 into pi. Okay. Then it is 0.3672, substitute here, Mn is there, Cw assumed as 1.25 wear and lubrication factor, and after simplification you get tangential load based on Lewis equation as 303.58 Mn square into Cv. Now compare this equation with this. So after comparison you will get Mn cube into Cv equal to 35.718. Assume Cv as 0.5 and calculate module as, and it comes out to be 4.14. Referring to the data book and tables in the data book, select the standard module which is 5 mm. Now using this standard module of 5 mm, calculate the velocity which comes out to be at 0.3 meters per second. Also calculate the CV velocity factor using this standard equation which comes out to be 0.4236, and again with this value of CV calculate this product which comes to be out to be 52.95, and which is much greater than this value which is already obtained with earlier values of C, this value. Okay. Now whatever the module we have chosen, that is 5 mm, is suitable. So from the strength point of view the design is safe. Then after calculating or fixing the module, calculate the gear parameters such as the pitch, diameter of the pinion, pitch diameter of the gear using the standard equations, center distance, face width, pitch, tangential load, axial thrust, all these things. Then now it is time to check the gear tooth for dynamic tooth load as well as wear load. Now by using this standard equation for dynamic load, we calculate FD, and for that we need to find out the dynamic factor C. So based on the velocity, you have to choose the permissible error from the figure, and with this value move to the table where C values are listed. There also the permissible error is there. You search for this value nearest to this or higher than that, and then take those values, substitute here, and then calculate the actual value of dynamic factor. Once that is calculated, substitute here and then calculate the dynamic load. This is so much, 20067.70 Newton. Then calculate the wear load by using this standard equation, and it is found to be 24190 K. Now this condition has to be satisfied. Fw should be greater than Fd. So this is Fw and this is Fd. So by this relation you get the value of K, and with this value of K move to the table wherein the VHN values for the pinion and gear will be chosen for the given tooth system and the material combination of pinion and gear. That is the end of the part 2. Thank you, students.